Hello everyone. So we are group 36 and our project is LLM augmented collaborative filtering for movie rating predictions on the 100K MovieLens dataset. So in our last meeting of our project, we were suggested by you that we should focus more on the movie and user genres, user demographics, and more on the release year and all the this metadata, right? So we took this idea and we rebuilt it rigorously. So our main focus was on that to generate a good prompt that focuses on uh, like we give it the movie and the all the data about the movie and also the user and with these details, so it have to predict the movie with like the rating for the movie, right? So we took that idea and we rebuilt it the whole project and tested it rigorously over the five folds and all, and it was the results were literally good. We also compared it against the CF baseline and hybrid of both. So yeah, so this was our project and let's do a walkthrough on the project. So our project is structured in the three parts. So first is the traditional collaborating filtering method. So here the user similarity and bias character predictions, and this was mainly the reference point of our project. The second part was the main approach where we use the LLM based approach. So this is the core of a project. We use a sentence transformer to generate the semantic embeddings for movies and users and then compute the ratings of the movie, right, through the cosine similarity. And the third part is the blend of the CF and the LLM based approach, because we want the best of both of the worlds. So this was our goal, that first we do the traditional and the LLM based approach, and lastly we blend both the approaches to get the best of the both worlds. So we spend our main time in this part only. So let me walk you through the how the LLM components actually work in a project. So we start with the training from the u1.base. From that we construct a test description of the every movie, like title, genres, and release year. So this is the simple one-line string. Then we also build a text profile for every user. We what movie do they look at, what ratings do they do, give to the all the like movies genres, and build a sentence that these users specifically like the crime and the thriller films, right? So both of these texts are passed to the sentence transformer. Specifically if I talk about the all mini lm v6 L6v2, which gives a 384 dimensional embedding vector. So then we compute the cosine similarity between the user vector and the movie vector. That similarity score is then what I would say, then percentile normalized and then scale to 1 to 5 ratings. So that is the full LM pipeline. No API calls, no GPT tokens. The LLM here is the embedding layer of the language model, right? So this is what it is actually designed for. So let's make it concrete with the real example that we used from the dataset, right? So we took the user 196, age 49, male, occupation is writer, okay, and the movie 50, like the Star Wars from the 1977, genres is action and adventure and sci-fi. On the left screen, you can see that how the movie text is built, like right, it's the title, genres, and years concatenated in the sentence, okay. On the right side we build the user profile, right? We look at the user 196 highest rated movies and we give it to the training module, like the Fargo, Flip, like the Pulp Fiction, Signs of the Lamb, Schindler's List, okay. And we extract the genres and build a sentence that this user enjoys the crime and drama, thriller type of movies, which include the Fargo and the Pulp Fiction, right? The main thing we have to notice here, that we are not giving the LLM the raw ratings, right? We are giving the semantic meanings, that what the user likes. So this is what allows us to handle the cold start users as well. Both the strings, the text strings go to the sentence transformer. Now we got the 384 dimensional embedding vector, which I talked back about that. Now what we compute is the similarity score between the user 196 vector and the Star Wars vector, the movie vector, right? So we get a score of 0.634 approximately. So here is an important detail. Raw cosine similarity for the movie lens content sits in a very narrow band, roughly 0.53 to 0.68. If we just directly scale this to the 1 to 5 ratings, every single movie will get about the 3.0, and that is the useless, right? So we use the percentile normalization. That is the intuition of the percentile normalization that we applied in the uh, like pipeline, right? So a score of 0.634 sits at the 71st percentile of all the training similarities, right? So we map that to the 1 plus 0.7 1 times 4, which gives 3.84, right, out of 5. So that's the actual rating in the test set for the test user 196, and the Star Wars is 4.0. So we are off by 0.16 on this example, and I think that is a good prediction, right? Cold start, right? This is the one of the strongest advantage of the LLM based approach. So for a new movie that has no history, no ratings, we fall back to a genre baseline, right? We look at the average rating for each of its genre, right? In the training paradigm. So and blend those averages and use that as a prior, and then we still apply the cosine similarity on top of it to personalize it. And also for a new user with no history, we use demographic fallback, right? We look at the average rating from the user, having the same occupation, same age, and the gender and all, and estimate their genre preferences and build a profile on that. Now the traditional collaborative filtering, a baseline like it cannot do this. If a user isn't there in the training matrix, it has nothing to do with it, right? So the LLM based approach or paradigm, I would say, gives a reasonable estimate even with the zero history. Look at the numbers, right? So these are the LLM results across all the five folds from U1 to U5. So the hit rate at 20 is 0.9995. So I would say it's near perfect, not perfect. So that means that if we recommend the top 20 movies, we almost always include at least one movie the user actually liked, right? But if we look at the NDCG, it averages at 0.7604 to be precise. NDCG measures the ranking quality, whether the movie the user likes appear at the top of the list or not just somewhere in the top 20, right? So 0.676 is decent, but we can anyway do better. So MAE is 1.14. The absolute rating prediction error is over one full star on average. So semantic similarity tells you about the what movies are relevant, but it doesn't tell you exactly how much a specific user will be like something, right? So this is the key limitation we found in our this. What we did, we learned from the LLM component. The now we talk about the LLM observations, right? So first, it's a strong discovery. Like near perfect hit rate means it knows what movie are relevant to the user's taste, right? But secondly, if we talk about the, it's a weaker at ranking, right? The NDCG at 5 is of 7.6, that is lower than the CF 0.84, right? So content similarity doesn't capture the order of the personal preferences well. And third, if you talk about the cold start, that is handled by our approach. The LLM can make reasonable prediction for users and the movie it has never seen, but the CF cannot, right? And fourth is the rating calibration, and I would say this is an issue in our pipeline, right? So MAE of 1.14 shows the semantic similarity doesn't translate clearly into the rating number, right? And the LLM know what is relevant, but it does not know how much the user will like it, right? So that's the exact gap that the collaborative filtering fills. Now let's talk about the result, the CF plus hybrid results. So if we talk about the CF alone, the NDCG is 0.814 and MRR is 0.906. A strong rate ranking performance, but it completely failed for the cold start users, and it has no semantic understanding, right? The In the hybrid model, we blend the 70% CF and the 30% LLM. Now look what happens. The NDCG at 5 goes from 0.814 to 0.862, and that is the 5.8 relative performance improvement, right? The MRR goes from 0.906 to 0.948, and that is the 4.6% relative improvement, and the hit rate at 5 is perfect 1.0, right? The semantic signal is improving ranking quality without breaking the CF's calibrated ranking accuracy, right? So, and the trade-off we actually came across is the MA only goes from 0.746 to 0.775, and I would say that is a small acceptable trade-off, right? The reason we took the 70-30 split and it worked well is that the CF contributes the strong personalization from the historical patterns, right? And while the 30% LLM weight acts like a semantic re-ranker, right? It slightly boosts the movie that are content aligned with the user profile, even if they haven't seen by the similar users before, right?
So, to summarize, what we have basically built and validated is that CF knows how much a user basically likes something. So, from the historical rating patterns, basically, and LLM will basically handle what is semantically similar. So, from the content or context understanding, the actual description of the movies and the users, the hybrid will basically get both the signals, and it's basically the merge of both, and the result is will always be better in the ranking metrics. Plus we have solved the cold start capability, we have the cold start capability of the LLM side, so the hybrid will be definitely better, combining both the advantages of normal CF based approach and the LLM based approach. We basically validated this across all five standard MovieLens folds, and NDCG at 5 improved by around 5.8 relative, and MRR by 4.6%, and the hit rate at 5 hit perfect 1.0, which is a really good thing. And this is exactly the approach suggested in our last meeting, basically to use the metadata and the user context and build a semantic understanding and combine it with the traditional CF for the best results. So our project was based on the LLM part, but to make it ahead and to cover an extra mile, we also compared it with the CF, and compared with the hybrid approach, we built the hybrid approach as well. And thank you for your time. This was group 36.